Okay, on notes 5.2, we're going to be looking at radicals and looking at the quadratic formula, which is another way to solve a quadratic equation. Radicals are like a square root, a cube root, fourth root. Okay, so to simplify these radicals, notice all of them are square roots, so we're going to use the factor tree. So looking at number 1, we have square root of 56. So when we're using the factor tree, we're going to start with the smallest number. So I'm going to start with a 2. So we're trying to figure out 2 times what number will give us 56. So that would be 2 times 28. And then we keep going until we have prime numbers. So a prime number is something that nothing will go into it besides a 1. So 2 is a prime number, but 28 is not. So we're going to continue with that. So I'm going to start with 2. 2 times 14. And then we can continue on 14, 2 times 7. 7, notice there's not anything besides a 1 that can go into that, so that's a prime number. So I'm going to mark out everything that I drew a tree on off of, and then I'm looking for my pairs. Your pairs will go in front of your radical. Whatever is left over will stay under the radical. So notice here I have a pair. I want you to circle the pair, and then you're going to box in whatever is left that doesn't have a pair. So the circled part comes on the outside. I'm going to bring out a 2 because I have a pair of 2's. Square root of 4 is 2. And then under the radical, we'll have left 2 times 7, which is 14. Those should be equal. So if you typed in square root of 56 on the calculator and 2 square root of 14 on the calculator, it should give you the same decimal. Okay, so looking at number 2, we have the square root of 324. You always want to check to see if it's a perfect square before you use the factor tree. 56 was not, but if you type in on the calculator square root of 324, you should notice that it is a perfect square. It equals 18. Okay, if you had used the factor tree, then you wouldn't have had anything left over at the end, so nothing boxed in. Okay, let's look at 3. So we have square root of 98. If you type in square root of 98 on the calculator, it's not a perfect square. So I'm going to start with 2. So 2 times 49 will give you 98. And then continue on. 2 will not go into 49, so we're going to go to the next one. So 7 times 7. We're circling our pairs, and that's the number that we will bring on the outside of the radical, so that's 7. And then I want you to box in anything that you do not have a pair of, and then that will stay under your radical. So 7 square root of 2 should be the same thing as square root of 98. Notice on 4 that there's a number in front of the radical. We're still going to use the factor tree to simplify the square root of 30, or 300, I'm sorry. And then notice if you plug in square root of 300 on the calculator, it's not a perfect square. So we're going to use the factor tree. 2 times 150. Keep going. 2 times 75. 2 will not go into 75, but 3 will. 3 times 25. And then 5 times 5. Okay, so then we're going to circle our pairs. We have a pair of 2's, we have a pair of 5's, and then we have left a 3. So whatever is boxed in stays under the radical. Now in this example, we already had a 5 in front. I'm bringing out a 2, so I'll multiply whatever I already have in front times 2, and I'm also bringing out a 5. So if you're bringing out more than one number, you'll be multiplying them. And then whatever is boxed in stays under the radical. So 5 times 2 would give you 10, times 5 would give you 50, square root of 3. Again, you could type in 5 square root of 300 in the calculator, 50 square root of 3. Those should be the same decimals. So that is simplifying radicals using factor tree. So first thing, always check and see if it's perfect before you use the factor tree. Okay, so now we're going to get into solving a quadratic equation using the quadratic formula. We've already talked about solving using factoring, so this is just another method to solving. So notice here, quadratic formula, and here's your formula here. It's negative b plus or minus the square root of b squared minus 4ac all over 2a. Okay, here's your standard form that we had talked about when we were looking at factoring. So you will find a and b and c first, and then you can plug into your formula to solve your quadratic equation. So it says solve each quadratic equation using the quadratic formula. You're leaving irrational answers in simplified radical form, which means we don't want our answers in decimal. We're going to leave it as a radical, so a square root in our answer. Okay, so first step is to put it in standard form. So set it equal to 0. Notice number 5 is already set equal to 0. So my next step will be to find a, b, and c. So a is the coefficient of x squared, notice on the formula, and then so that's 5. B is the coefficient of x, so that's negative 4, and c is your constant, which is your number without the variable, so that's negative 2. Okay, so we're going to plug in to your formula, so x equals, notice on the formula it's negative b is a negative 4, plus or minus the square root of b squared, so negative 4 squared, minus 4. A is 5, and c is a negative 2. That will be over 2 times a, which is 5. Okay, so once you have typed in or plugged in your a, b, and c into your formula, you're going to find the number that's under the radical. Okay, so that's going to be negative 4 squared is 16. That would be 20, so that would be plus 40. So under the radical, you should have 56. So that would be x equals 4 plus or minus the square root of 56 over 10. And if you want, you can type in everything that's under the radical in the calculator all at once and get that number. So negative 4 squared minus 4 times 5 times a negative 2. Okay, so from here, we need to simplify the radical, so that's square root of 56, so like what we were just doing at the top. So I'm going to come over on the side and use factor tree. So that would be 2 times 28, 2 times 14, and 2 times 7. You're bringing out your pairs, and then we're leaving whatever is not a pair, so 2 and 7. Okay, so let's rewrite this as 4 plus or minus the square root of 56 we just found to be 2 square root of 14 over 10. Now, once you get to this point, we will not be able to add this radical here, so 4 plus or minus 2 square root of 14. We can't add those two together. Okay, a radical is just like a variable. If they don't have the same radicals, you can't add them. Okay, so what you need to look at from here is look and see if these outside numbers can be reduced by the same number. Notice that we can reduce all of them by 2, not the number under the radical, but only the numbers on the outside you can reduce. So x would equal, that would be 2 plus or minus square root of 14 over 5. And you could write a 1 in front of that square root of 14 if you wanted. Okay, so you divided all of those by 2. Since you can't add it, that would be your answer there. Okay, so now we're going to look at 6. Notice that it's not in standard form, meaning that it's not set equal to 0. So first step would be to subtract 4x. On standard form, we have x squared first, then your x, so minus 4x, and then your constant, so minus 12 equals 0. So I'm going to find A, B, and C. A is the coefficient of x squared, so that's a 1. B is the coefficient of x, so that's negative 4. And C is a negative 12. So knowing that information, we're going to plug into our quadratic formula. I'm going to go ahead and recopy that down here. Okay, so I have x equals, on your formula it's negative, and then b is negative 4, plus or minus the square root of negative 4 squared minus 4 times 1 times a negative 12 over 2 times a, which is 1. Okay, so again, I'm going to find the number that's under the radical. So if you're typing it all in the calculator, make sure you just type in the numbers under the radical and don't type in square root. Okay, so this is going to be, that'll be 16, and that would be plus 48. So if you add those together, you should get 64. So we should have x equals, that'd be 4 plus or minus the square root of 64 over 2. Okay, so on number 5, from at this point, when we had our radical, we then simplified it using the factor tree. But notice square root of 64, that is a perfect square. The square root of 64 equals 8. So if you no longer have a radical, you should have 2 whole numbers as your answer. Okay, so I'm going to set up 2 different things. I'm going to have x equals 4 plus 8 over 2 and 4 minus 8 over 2. Now the reason why I didn't do this on number 5 was because we didn't have a perfect square, so we had a radical and we weren't able to add those up. So if it's perfect, you should get 2 whole numbers for your answer. So 4 plus 8 would give you 12 divided by 2. So x would equal 6. And then you would get negative 4 over 2, which is a negative 2. So to check it, same way when we were factoring, you could plug in those values. If you get a whole number, plug it in, and then it should be true into your original equation. Okay, let's look at 7. First step is to set it equal to 0. Remember whenever we were factoring, we always wanted our a to be positive. You don't have to have that with the quadratic formula, but since we have to have it for factoring, let's go ahead and still keep that x squared term positive. So that means I'm going to subtract 4x and add 1. So that's 2x squared minus 4x plus 1. Okay, so I'm going to find a, b, and c. A is 2, b is negative 4, and c is 1. So plugging into your formula, it's negative b, so negative and negative 4, plus or minus the square root of b squared minus 4 times a times c over 2 times e. So from at this point, remember you're finding the number that's under your square root. So when you plug that in, you should get 16 and then that would be minus 8, so that should equal 8 under the radical. So you have x equals, that becomes a positive 4, plus or minus the square root of 8 over 4. Okay, so check your radical. 8 is not a perfect square, so we're going to have to use the factor tree. So come on the side, 2 times 4 and 2 times 2. So you're trying to find the pairs, so we have a pair of 2's, and then we have 1, 2 left over. So we're bringing whatever we have a pair of, a 2, on the outside, and whatever is boxed in stays on the inside. So this would be the same thing as 4 plus or minus, bringing the 2 out, and then we have left the 2 under the radical over 4. Now, once we simplify the radical, you're looking at only the outside numbers and see if you can reduce them. They all can be reduced by 2. So that would be x equals 2 plus or minus. I could put a 1 there, but it's not needed. So I'm just going to put square root of 2 over 2. Now remember, you're not ever reducing the number under the radical, only the numbers on the outside. Since I can actually add and subtract the square root of 2 to 2, that would be my answer. Okay, you'd be doing the same thing on those next 2 examples. So we're going to go ahead and go on to using the square root method. Okay, so that was the quadratic formula. Now we're looking at square root method. Alright, when you're using the square root method, it only works when you're missing an x term. So square root method, when you're missing x. Okay, so notice on number 10, we have x squared minus 49 equals 0. We don't have an x term. Okay, so when you're using the square root method, the first step you will do is get your x squared by itself. So we're going to add 49. So you have x squared equals 49. And then from here, we're going to get rid of the squared. To get rid of a squared, you do the opposite of squaring something, which is taking the square root. So we're taking the square root of both sides. The square root of x squared is x. The square root of 49 is 7. Now, you will have 2 answers. If you're solving a quadratic, you'll have 2 answers. Right here, we're trying to figure out what number squared gives us 49. So 7 and negative 7, if you square it, should give you a positive 49. So on your square root method, make sure that you have a positive and a negative answer there. Okay, so number 11, so get x squared by itself. So add 27. 3x squared equals 27. Divide by 3. So x squared would equal 9. So we got our x squared by itself. Once it's by itself, you're going to take the square root of both sides, because whatever you do to one side, you have to do to the other. So the square root of x squared is x. Square root of 9 is 3. Remember, we could plug in a positive and a negative 3 in for that, and it should give us a positive 9. So make sure that you're putting a positive and a negative answer whenever you're using the square root method. You should have 2 answers. Okay, looking at number 12. Add 48. And then we're taking the square root of both sides. Positive and negative. Now, notice right here, square root of 48. The other 2 have been perfect squares. 48 is not a perfect square, so you will have to use your factor tree. 2 times 24, 2 times 12, 2 times 6, and 2 times 3. Okay, you're finding your pairs. And then box in what you don't have a pair of, so 3. Okay, we're bringing out 2 2's because we have 2 different pairs. So that would make 4 on the outside. And then square root of 3. So if it's not a perfect square, make sure you use the factor tree to simplify the radical. Also make sure you have 2 answers, positive and a negative. Okay, looking at this last one, we're going to add 60. You have 10x squared equals 80. Divide by 10 because you have to get x squared by itself before you can take the square root. So then we can take the square root of both sides. You get x equals, remember, positive and negative. 8 is not a perfect square, so use your factor tree. We have a pair of 2's, and we have a 2 left, so that stays under the radical. So positive and negative 2 square root of 2 would be your solution. And you could plug those back into the equations there and check it and make sure that it's true. So your square root method only works whenever you have an x squared and you're missing the x. Okay?